You really love chemistry, right? But why am I talking about pressure? Why am I talking about physics? Well, this is how we have to talk about external and internal respiration. So again, it's all about moving things from high to low pressure. So here's a cartoon. If you printed it out the sides, maybe you want to draw on these. So here we have a cartoon of our alveoli and capillaries in the pulmonary capillaries. Again, this is pulmonary circuit now. So here we have the alveoli. You breathe in, inhale, you're bringing all this fresh oxygen in. So in the butt, inside your alveoli, the average partial pressure of oxygen is around 100 millimeters mercury. I'm only using the number here for clarity's sake. So when you get blood delivered from via your pulmonary trunk, again to pulmonary veins, and then to your pulmonary capillaries. So the partial pressure of the blood, deoxygenated blood, is around 40 millimeters mercury. So what happens once you get the blood, deoxygenated blood, interfacing with the oxygen or the air in the alveoli? Well, again, partial pressure is pressure. And again, does pressure move from high to low or low to high? Again, it always moves from high to low. So which way will the oxygen go? So the oxygen will go, again, from high to low. So this is how you move oxygen from your alveoli into your blood. It's due to that difference in partial pressure of oxygen. So eventually it reaches 100 with every time you breathe. So eventually this reaches an equilibrium where the partial pressure of blood leaving your pulmonary capillaries is around 100 millimeters mercury. So again, wait. So those of you who have been taking notes might be like, okay, why is sea level atmospheric partial pressure 160, but why is the alveolar partial pressure lower? Well, the funny thing about partial pressure is that, again, it's about how much it takes in the pressure in your air, but also the percentage of that each gas in the mixture of air that you breathe in. So humidity. Water can also be a gas. So the inside of your body is very wet and humid, right? So as you breathe in air, even though the air inside your lungs is more humid than the air you breathe out, when you add water, vaporized water as a gas to the air you breathe in and the air you're inside your body, it's actually going to push other air molecules out. So now water is taking up some of that partial pressure. So again, water can also be a gas, and it displaces other gases, including oxygen as well. So it's like one of those crowded rooms, and then say you have like a party, and then all of a sudden all these other people like from another college come in. Will there still be room for everyone else? No, they might start to push out other people. Same with water once air gets into your lungs. Once you have humidification of the air, it starts to push out other gases as well. Right, so capillaries absorb oxygen constantly. So again, you also have slow air turnover. But believe it or not, every time you breathe in, only a fraction of each quiet breath reaches your alveoli. So most of the air in your lungs during one breath stays there. So this is another reason why alveolar partial pressure is lower than your atmospheric pressure. Okay, so now we have that oxygenation in via the alveoli and the pulmonary circuit. Now you're pumping all that blood to the rest of your body, that oxygenated blood. And actually, remember when we left the pulmonary circuit, it's around 90 or 100. But what we see here, ooh, that was a little quick, but let's replay that. So the funny thing is that once it reaches systemic capillaries on the arterial side, it drops a little. You do lose a little oxygen along the way, so it drops to around 95. But what happens once it interfaces with the interstitial fluid? Well, now the interstitial fluid has a lower partial pressure, so again, things go from high to low. So 95 is greater than 40, so the oxygen is going to go toward and diffuse in the interstitial fluid, and then your cells are going to uptake that oxygen as well. And it's going to uptake all that oxygen, and finally it's going to remove oxygen from your blood in the systemic capillaries, and once it leaves the systemic capillaries, it drops back to 40 millimeters mercury. Now once it's back here, well, what does it do? Back to the pulmonary circuit, the oxygenated blood pumping, re-entering your heart via the right atrium, pumping out through your right ventricle, back to the alveoli and in your lungs, and the whole cycle starts over again. Alright, so yep, that's what we have here. Alright, so what happens next? Well, remember that cellular respiration equation that we briefly mentioned earlier in the semester, and if you've taken biology, you've probably already seen this equation. So what do we have here? We have glucose plus oxygen, and then due to cellular metabolism, what does this produce? Carbon dioxide, water, ATP, and heat. So you take in oxygen and you produce carbon dioxide. So what do you do? So again, carbon dioxide is a byproduct of metabolism. So what happens to carbon dioxide? So we just talked about how oxygen is transported from your lungs into your bloodstream and from your bloodstream to your tissues. So let's talk about carbon dioxide. So again, your cells take in oxygen, and through that cellular respiration equation, they produce carbon dioxide. So how do you get rid of that carbon dioxide? Well, you're going to put it in the blood. So the interstitial fluid, your partial pressure of carbon dioxide is around 45 millimeters mercury. And actually, don't get too hung up on the numbers. I just generally want you to know, like, is it high or is it lower in the systemic capillaries and pulmonary capillaries, interstitial fluid, alveoli? So which way do the gases flow in external and internal respiration? So again, but I'm showing this to show the numbers to show you how it does flow. So and diffuses. So when blood enters systemic capillaries from the artery side, what do we see? Well, we see the partial pressure is 40. So once it interfaces with the interstitial fluid, which way will the carbon dioxide go? Will it go toward the interstitial fluid, or will it go into systemic capillaries? And remember, this time we're talking about carbon dioxide. So which number is bigger? This number, right? So again, pressure moves from high to low. So the carbon dioxide is going to move into the blood entering systemic capillaries. So this is going to bring the partial pressure of the gases dissolved in the blood up to around 45 millimeters mercury, and once it leaves the systemic capillaries, it's around 45 millimeters mercury. And where does that go? So that eventually goes to, again, the right atrium, then the left, or the right ventricle, then to your lungs and the pulmonary capillaries. So we're talking about carbon dioxide now. So again, we do have that 45 millimeters mercury carbon dioxide, but once you get to the alveoli, so the partial pressure of carbon dioxide is 40. Which way does the carbon dioxide go? Again, pressure moves from high to low. Which number is higher? Again, it's in the blood, so the carbon dioxide is going to move from the blood into the alveoli. So this is going to move and every time you breathe out, this carbon dioxide is going to be excreted into your environment, and now you have less carbon dioxide dissolved in your blood. This can go back to the rest of your body. So this is how you transport both oxygen and carbon dioxide.